Okay, so in this video I want to just digress a little bit to talk a bit about logarithms and exponentials, just as a way of trying to give you the tools to make simple calculations, simple back-of-the-envelope calculations using exponential equations. So I just want to go right back really to talk about logs first of all. So what is a logarithm? So let's go back even a step further and think, how do we write numbers, say like 1,000? We can write that as 10 to the 3, or 100, we can write that as 10 to the 2, and 10 we can write as 10 to the 1. So if we're going from 1,000 to 100, we're dividing by 10. Here we're dividing by 10. If we divide by 10 again, we get to 1. And can you see here the exponent is going down from 3 to 2, 2 to 1, 1 to 0. Let's keep going, divide by 10. Now we get to a tenth, or 0.1. If we keep doing this pattern, that gives 10 to the minus 1. And again. Okay, so we can keep going on forever. I'm not going to, but I just want you to see that pattern. Okay, so what we would then say, so the logarithm is the power to which the base is raised. Let's just think about that for a moment. So the logarithm is the power to which the base, in this case the base is 10, is raised. So the logarithm to the base 10 of 1,000 is the power to which 10 has been raised. So that's 3. The log to the base 10 of 100 is the power to which the base has been raised. So that's 2. The log to the base 10 of 10 is 1. Okay, so if you notice, log to the base 10, I could have written that as 10 to the 3. Yeah, I could have just written that ever so slightly differently, but it's the same thing. I'm just trying to show you, get familiar with the notation. We tend to leave out, for log to the base 10, we tend to leave out this little 10 down here. So log of 1 is the power to which the base was raised, so that's 0. Log of 0.1 is the power to which the base is raised, that's minus 1. Log of 0.01 is the power to which the base is raised, and so on. Okay, so the log is the power to which the base is raised. Now, you're more familiar with log to the base 10, so that's what I've started with. But you can also have log to the base e. So a natural log is this thing ln, which is log to the base e, or log e. So rather than write log e, we write ln. Now, if I say, for the sake of argument, I wanted to look at e to the 3, if I put that into my calculator, you might want to do the same. Maybe pause me for a minute. Just do e to the 3. You'll see that the number you get is 20.1, or thereabouts. So the natural log of 20.1 is the natural log of e to the 3, which is 3. Okay, it's the power to which the base has been raised. So I took e and I raised it to the power of 3, and then I said, well, what's the ln of e to the 3? It's just the power 3. Okay, so if e to the 2 is 7.4 or thereabouts, then ln of e to the 2 is ln of 7.4, which is 2. E to the 1 is 2.718, da, da, da. So the ln of 2.718, da, 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 is 1. E to the 0, do it on your calculator, but anything to the power 0 is 1. So the ln of 1 is 0. We can do this whole same process again. Let's just get you the feel for this idea that what the log is. The log is the power to which the base has been raised. So we can have log to the base 10, and we can have log to the base e. Right, so the other thing you need to think about, so what we want to do ultimately is we want to think about this equation c equals c naught e to the minus k e t. Because what we might want to do is to get a value for t, and in order to do that we'd need to rearrange this equation to make t the subject of the equation. At the moment t is up in this power, so we're going to have to use logarithms to rearrange this equation. So the other thing you need to think about, or need to recall from secondary school maths, is this idea of manipulating powers. So if you remember, if you took 10 to the 2 and you multiplied it by 10 to the 3, that's 100 times by 1,000. That is 100,000, which you could also write as 10 to the 5. So if you remember, if you multiply two numbers that are expressed to a power, you just add the powers. Okay, so that was 10 to the 2 plus 3. So anything 10 to the a times 10 to the b is 10 to the a plus b. And because the logarithm is the power to which the base is raised, so the log of a plus b is the log of a plus the log of b. We could also look at divide. So let's go for 10 to the 3, 10 to the 3 divided by 10 to the 2. That's 1,000 divided by 100. That is going to be 10 to the 3 minus 2, which is 10 to the 1. So that is just 10. Okay. So more generally, 10 to the a divided by 10 to the b is 10 to the a minus b. So if we have log of a over b, a divided by b, that's the log of a minus the log of b. Okay, so what we need to also remember, there's one more rule that we need to remember, is if we have 10 to the 2 all to the 3, that's the same as 10 to the 2 times 10 to the 2 times 10 to the 2. which is 10 to the 2 plus 2 plus 2, which is 10 to the 6. So if we have 10 to the a all to the b, that's 10 to the a times b. Okay, so that's a little bit about logarithms and powers, just to remind you of some maths that you might have done a while ago. So in the next video we're going to go on and use this to have a look at this equation and manipulate this equation.